Hello, my name is Carlos Moran and I will present an article related to my thesis, and this article is a novel magnetic MIL-101 iron titanium dioxide composite for photodegradation of tetracycline under solar light. In this presentation I will talk about this article and I explain each section, and at the end of each I will say a critical analysis on this same part. First, about the paper. Um, this article belongs to Hazardous Materials magazine and was published in 2019, and the authors are Lei He, Yanang Dong, Jane Sheng, and Jackie Shang. And something that we can highlight are the keywords. For example, MOFs, magnetic, photodegradation, solar light, and tetracycline. Because they which give us an idea of what this article may be about, but the most important thing is the impact factor of this magazine, which is 6.434. And next, in the title, it is a novel magnetic MIL-101 iron titanium dioxide composite for photodegradation of tetracycline under solar light. I think that is very switchable because it says in a few words the theme of the work, the chemical species they use, and the energy they apply in the degradation. And okay, and now I speak of the abstract. And the abstracts in this research, they synthesize the composite MIL-101 iron titanium dioxide to apply it in the photocatalytic degradation of an antibiotic called tetracycline under sunlight. The material was characterized by XRD, TGA, SEM, TEM, BET, and XPS. This composite showed magnetic properties by a treatment that had to be synthesized, and this draws much attention because the advantage that the material provides by such a material are many, including the easy separation of the solution when you use a magnet. This is faster, and this is cheaper than using a conventional separation method. Something that they also mention is that it is a pleasant material with the environment, and they degrade 92.76% of tetracycline that had a concentration of 20 ppm under sunlight radiation in 10 minutes. Well, in this section I think that saying that the composite is a pleasant material with the environment is something false, since we will see later the methodology that they use, and we will realize that to synthesize this material and high energy expenditure is made. Also, something that does not they mention that they had a more efficient compound in the degradation of the tetracycline, which is similar but without having the magnetic properties. Well, the next part is reagents, and is tetracycline, acetic acid, terephthalic acid, iron chloride exhydrate, titanium oxide, dimethylformamide, and methanol. Well, the next part is experimental methodology, and the synthesis of this composition was by a isothermal method, and the methodology is simple, but it invests many hours to achieve it. They mixed iron chloride exhydrate and terephthalic acid and titanium dioxide and acetic acid in dimethylformamide, and thereafter place the mixture in a steel autoclave at 110 grades Celsius for 20 hours. Next, the solution was cooled naturally, and after that the solution was filtered to obtain a brown solid, and the product was purified with hot dimethylformamide and methanol and dried at 60 degrees Celsius under vacuum. Finally, to have the magnetic property, the product was heated at 350 degrees Celsius for 20 minutes and then allowed to cool naturally. About this methodology, my critical analysis is that it takes many hours to achieve the synthesis, and in addition to the energy expenditure is high for the use of the autoclave for 20 hours without taking into account when they purify and re-dry and then burn it. Without the aforementioned, I think that this method is not that pleasant with the environment. And well, next, this composite was characterized by X-ray diffraction to identify its crystalline phase, by TGA to study the thermal stability of the MOF, by SEM and TEM to analyze the morphology of the samples. BET was used to calculate the specific surface area, pore size, and pore volume, and the XPS was used to analyze the chemical elements in the iron MOF. And I think that they were the adequate techniques for the characterization, but also it would be necessary to release some extra as UV spectroscopy of diffuse reflectance to be able to calculate the EG. And now I will show you the results obtained and the different experiments that were carried out. First, the photocatalytic degradation of the tetracycline. And in this slide we can see the effect of the degradation of 20 ppm of the tetracycline using different catalysts. Under visible light, we can see that the catalyst magnetic MIL-101 iron titanium dioxide is the one that reached a higher percent of degradation in 3 hours. In the next slide, we can see the degradation efficiency of tetracycline using different catalysts, but now under sunlight and under ultraviolet light, we can see that under ultraviolet or solar light in 10 minutes the catalyst MIL-100 iron titanium dioxide reached 90% of degradation, and the magnetic compound reached it after 80 minutes using sunlight, but with ultraviolet light is far below. In this other slide we can see the effect of the concentration of tetracycline and its degradation under sunlight using 0.8 grams per liter. Catalyst is magnetic MIL-100 iron titanium dioxide at pH 7, and it is clear that it is faster to reach high percents of degradation when the concentration is less to tetracycline. This catalyst is more efficient. In this other slide we can see the effect of different dose of magnetic photocatalyst MIL-101 iron titanium dioxide to degrade 20 ppm of tetracycline under sunlight at pH 7, and we can see that the best dose is 1 gram of catalyst per 2 liter. In this other slide we can see the degradation of 20 ppm of tetracycline, but now with different types of radiation and using 0.8 grams per liter of catalyst magnetic MIL-101 iron titanium dioxide at pH 7, and we can see that using ultraviolet light or solar the results are very similar, but in this case it is better to use visible light because we use lower energy than when you use ultraviolet light. And my critical analysis of these experiments is, well, I think that they were adequate to determine the best conditions for the reaction, but the experiments that will also give us a better result will be to determine the degree of mineralization of the tetracycline. I think that we needed to experiment to calculate the LG of the catalyst, but they don't do it. And finally, the conclusion of this article is that the new magnetic MIL-101 iron titanium oxide composite is very innovative because it is magnetic since it gives the advantage of being easily separated from the solution in which it is found, and therefore saves time and money, and also has the advantage of degrading a high percent of a complex antibiotic in a short time using solar radiation energy. And the tests carried out that determined the best reaction conditions were very efficient and showed excellent results. And on the other hand, to obtain this catalyst, they use a methodology that needs a high energy expenditure, since when synthesizing by a solvothermal method and taking 20 hours, it is evident that the energy expenditure is greater. Therefore, it will be necessary to achieve the synthesis of this composite for a more pleasant method with the environment. And this is the reference of the article, and thank you. Gracias.